Cool. Hey, everyone. Thanks for making it in this morning. I know, coming into the early sessions isn't always the easiest to do, so thank you for finding some time to come hang out with me, and we'll talk a bit, about Kotlin and then a bit about C#. When I do this talk, it feels a little more natural to sort of do it as a conversation because it's all sort of built around my experience being a C# developer, learning Kotlin, learning what I can build with it, learning how to build with it, sort of comparing and contrasting a lot of that. So sort of as you guys are following along with me as I do some of these comparing and contrasting, if you have questions or anything at all, throw your hand up. I'm happy to answer them sort of on the spot. If it's something that I'm going to get to later, we'll talk about that when we get there. But I'll also sort of ask you questions, sort of gauge where you guys are at in terms of what you use C# for, what you're interested in using Kotlin for. So I'm Alex Dunn. On the internet, I'm not Alex Dunn. You'll find me as Suave Pirate because my name is so basic in the US that I'm not the only Alex Dunn that works with Microsoft technology. So even if you look up Alex Dunn Microsoft, there's like 3 devs at Microsoft named Alex Dunn. So when I was like, all right, I'm going to start having an internet presence, I started looking up how I can use my name and stuff like that. Nothing without a ridiculous combination of numbers and letters at the end. So I use a name generator I wrote when I was like 8 years old. Boom, Suave Pirate. So if you need to find me, you'll find me there. I'm a Microsoft MVP for .NET technology, so all the dev tools and stuff like that, hence the sort of background in the C# space. And I'm also a Pluralsight author, and I'll talk about my course towards the end, but most of my Pluralsight content is around Kotlin, so you can sort of see how doing a lot of .NET work, a lot of C# work, a lot of Kotlin work, I sort of have both aspects that make it really interesting to come do these talks and introduce a new language to those of you who haven't used it before. So I want to sort of preface a little bit that this isn't a, hey, ditch C# and use Kotlin because Kotlin's the new and hot language. And it's definitely not, I'm going to prove that Kotlin sucks and C# is still awesome. I want to sort of lift both languages up because a lot of the features that you sort of see in both languages, and we'll get into this quite a bit, are very similar, and they're both awesome. And we can do a lot with both languages. And I'm hoping in the future potentially use them actually together, which would be pretty cool. So to be a little specific, I'm talking about Kotlin 1.3. This is a more recent release, so it's been interesting as I've sort of run this talk over the last year and a half. I've got to sort of build on it quite a bit because Kotlin's growing crazy fast. They're throwing features out like every 3 months or something like that when they're doing these minor releases. So it's been cool to be like, oh, now I can add this, and I can compare how I would do that in C# versus Kotlin. And now, C# is also growing really fast. I don't know if any of you guys have messed with all the C# 8 features. We'll talk a little bit about that towards sort of the end. But there's a lot of sort of paradigm between the two, and they both grow crazy fast. So how many of you guys have actually used Kotlin before or even know what it is? That's actually not bad. Most of the times it's like someone's like, it's me. How many of you guys didn't know Kotlin was a programming language before you walked in this room? There it is. Yeah, every time someone's like, all right, I'm going to learn about this Kotlin framework and write .NET. No, we're talking about a whole new language here. So let me intro you guys to Kotlin a little bit. Kotlin is a statically typed language. It was originally written for the JVM. And sort of when I was introduced to Kotlin, everyone was saying, this is what's finally going to make you not have to write Java ever again. So I was like, all right, I'm invested already. But it's written quite a bit differently, and you'll see that as we get through the examples. But you can write it with a lot of object-oriented style, it's what its sort of roots are in. But you can also write functional style programming with Kotlin, which we don't necessarily cover in this because, again, we're sort of comparing C#, but definitely something worth looking into. And like I said, it runs on the JVM, but it does also have a lot of cross-compilation capabilities. So you can actually compile Kotlin to JavaScript, and you can compile it to native, which sort of expands the horizons of it quite a bit, which is pretty cool. So Kotlin was invented with a pretty sort of distinct set of expectations, right? So it wasn't just there to be another language. It wasn't just there to also get rid of Java, but it was there to help reduce the verbosity that a lot of Java developers have to go through. How many of you guys have written Java in the last 10 years or so? Yeah, see? How many of you guys enjoyed writing Java in the last 10 years or so? Okay, most of you guys are in the right place then because we're going to talk a lot of trash about Java today. So again, the goal is to reduce verbosity. So we're going to write more efficient code. It's still going to be easy to read. You know, it's not like we're going in and reading Racket and there's parentheses everywhere or anything like Objective-C, which is just terrifying to look at if you didn't write the code. But it's there to support many different styles too. Like I said, you can write object-oriented Kotlin, you can write functional Kotlin, you can write procedural if you're into that. And with all of those sort of reduced verbosity and the ability to support all these different styles and preferences, it still needs to support backwards compatibility, which means you get 100% interoperability with Java, with anything that runs on the JVM. So you can write, you know, interconnect your Java, your Scala, your Kotlin, your Clojure, if you're into that. And the goal being, like, let's just write more code, let's write it faster, let's get stuff out. You know, we sort of live in a crazy fast-paced software world right now, and Kotlin does a great job at making it a bit easier to just get stuff out that's written well and written strongly. So I like to talk about this. There's this concept in psychology called speech convergence. It basically is like when you put someone in an environment where someone speaks either with a different accent or a different language, they sort of tend to fall into that accent when communicating with that person. Any of you guys that have talked to me, you might have noticed me really struggling not to like sort of copy your accent. I don't necessarily mean to mock it, but I'm super bad at this. But we find it interesting, you know, looking at sort of the newer programming languages that come up. They take the roots in other languages, and you can sort of see as new features are built for one, another one's falling right up. Maybe they do something slightly different. And I see a lot of that with C# and Kotlin, at least from my observations. But Kotlin straight up says that it brings in a lot of inspiration from languages, obviously like Java, explicitly C#, JavaScript, Scala and Groovy, and also TypeScript as well. So if any of you guys have written TypeScript, you're going to see a lot of similarities in sort of the typing styles and stuff like that. And it's actually how they get stuff to work as a compilation from Kotlin to JavaScript with type safeties. They actually pull in TypeScript types, which is pretty cool. So to start, I want to do some sort of side-by-side. So we're going to look at sort of the foundational stuff. You'll see C#, you'll see Kotlin, and I want to just sort of get you guys understanding what the basics are, and then we'll talk about some of the platforms that they support, why you might actually be interested in using it, and then we'll sort of do a little bit of a deeper dive into the really cool stuff. All right, first things first, let's look at a POCO, right? It's the sort of the foundation of our C#. It's the foundation of our Java. It's our basic, super basic class, right? Plain old CLR object, or in this case, plain old Java or plain old Kotlin object. So I'm a big dog fan. I sort of started a rescue league and stuff like that. So all of this stuff's going to be dog related. So just prepare yourself for that. So we have a class named dog. It's got a name, it's got an age, and it's got a breed property. Super basic in C#. We use these all the time. In Kotlin, this is sort of what the same thing would look like. We have our class dog. It's got these three properties, name, age, breed. You'll notice the camel case naming convention. I'm sorry if you don't like that. That's too bad. One of the other things you'll probably notice right away is that we actually have explicit null reference types. So something that came out in C# 8 for nullable reference types is default in Kotlin. There's no way around it. So you have to initialize something either in the constructor or in the properties declaration. So in this case, all of these are nullable types. We're initializing them with null. There's a few different ways you could do this. I won't get into that, but for the sake of seeing them side by side, that's what we're looking at. So when we're constructing our objects, we need to have the same properties, and we also need to have the ability to override those same constructors. So in this case, we have our default constructor, and then we have another one that takes in all the properties, and then we're setting them, right? In Kotlin, our default constructor is actually defined in the signature, which you may have noticed in the previous slide when we had the sort of open and closed parens. It's not required if you are only going to do a default constructor with no parameters, but when we override or overload constructors, rather, we need to just define constructor, pass in the parameters, just like you sort of see in C#. This is similar to other languages too. JavaScript class constructors can look like this, and then the same thing, properties all the way down. Kotlin also has this concept of data classes. Any of you guys go to the .NET panel yesterday with Damien and David Fowler and stuff like that? Someone asked sort of at the end, when are record classes coming, right? And they were supposed to be in C# 8. They got punted back. We have the idea of records in Kotlin, and we call them data classes. And it's the same as any other class, except you slap data in front of it. And then in the constructor, you're actually defining your properties and the constructor at the same time. So this whole top line here is an actual class declaration. It's the definition and it's the constructor to create it, which is really cool, and it's used a lot. You can use this without data classes too. You can sort of just define properties in the constructor by just giving it either val or var or something like that. And then we just construct it like this. When we have a data class, we get the hash set automatically, we get copy automatically, similar to doing stuff with structs in C#, but we do get a bit more too. One of the other things you might have noticed is that we have this sort of concept of val versus var. And this is also something that's pretty unique to Kotlin. So var being a variable and val being a value is similar to having a read-only property in C#, except that val and var is sort of a concept exists everywhere. So it's more like having const versus var in JavaScript, if you're familiar with that. So value can only be set once when it's initialized. If you aren't initializing, you're going to get a compiler error. If you try to change it, you're going to get a compiler error. But var, you can set it at sort of any time, but it does still need to be initialized at the beginning. That's just how everything in Kotlin works. So in this case, we have our var name, which can be set again, and we also have the value read-only name. And then in this sort of bark function, we are trying to set the val to something else, and that's not going to work when we set it at the bottom, but we can set sound2, which is a variable, to something else, totally fine. So for those of you who have written Java, you probably know that getters and setters don't exist, and we have to write and do our encapsulation all manually. We have to have our private properties or private fields, and then we have to explicitly write getter functions and setter functions. In C#, we have the awesome ability to write getters and setters, which at compile time actually build the same similar methods behind the scenes with sort of the get underscore and the name of the property. But in Kotlin, we also get the same thing. And this actually does some pretty cool cross-compatibility stuff in order to get this to work in Java, right? So everything that we're seeing happening right now in Kotlin, all of this still has to work when we're consuming it in Java. So although we have a property here called age and it only has a getter, when we look at this and try to access it in Java, we're actually going to have a generated function called getAge, just like you'd expect in sort of the similar Java syntax. So not only does it make it cross-compatible, but we also actually get like the sort of Java convention of getting and setting properties with the same naming convention and everything, which is a pretty neat solution they had put together. So in this case, we have our dog with a int age, which is doing a little bit of a calculation based off of the current date and then their birthday date time. And then on the same side, in Kotlin, we're doing the same thing. We're doing a get, except Java doesn't have a very good date object, so we're working with that sort of trash and then doing a whole bunch of actual math to calculate the difference, but same idea. So sort of one of the last few things I want to talk about in the basics is just methods and functions. So in this case, we have a dog adoption service. It's a class. It has two different methods. It has a void method, which is just called adopt dog. It's not going to return anything. And then we have our method called adopt dog that actually returns an object, right? And that object is defined below. In Kotlin, we have functions, which we just call fun, because functions are fun. They get to do all the cool stuff. So in this case, we have another data class up top. Again, you can sort of see the verbosity in terms of like, look at how big this C# object is written versus literally 3 lines of code that could actually still be 1 line of code in Kotlin, which is pretty cool. And then we have our different funs all the way down, and as you can sort of see how they're executed. One other thing you're going to notice here is that the constructors in Kotlin don't use new at all. We just call the name of the class with the parens. We understand that's a constructor. Why do we have to use the new keyword everywhere? We don't need to read so much while we're writing our code, which is pretty cool. Another cool thing that C# does is null coalescing and propagation. So we get both of those. Great features. So in this case, we're looking at the same dog. We have the breed lifespan and then sort of the dangerous lifespan, where the lifespan is checking that breed object is not null, and then checking the average lifespan. And if not, we're going to return 0 instead. We also have the dangerous one, in which case we're actually going to assume breed is not null. If it is, we're going to get a null reference exception when we try to access that. In Kotlin, because we have nullable reference types from the beginning, we have to explicitly check whether it's not null or it is null. And we make the assumption, we make it clear that in this dangerous lifespan getter, breed better not be null. And it's actually a nice sort of signal when you're reading the code to go, okay, I know sort of the dangerous path I'm taking here. I know what I'm playing with. I can work under the assumption that breed's not going to be null, but every time I'm sort of reading through that code, I'm going to see the double bang there and know that I'm making that assumption, I'm making it hard, but we get the same sort of question mark for the propagation that can go through. And then the only other sort of naming convention thing is instead of the double question marks or the double we get the question mark and then the colon to do sort of the same thing. It's more like a in-between turn area that they do. So, any questions on sort of the side-by-sides? If not, I'm going to sort of compare and contrast the platforms that we can build for, and then we'll get into sort of the juicy bits of the code. No? Cool. So, a lot of these are my opinions, or sort of what I see in terms of trends, but I sort of want to highlight what are kind of the primary developer platforms for C#, then do the same thing for Kotlin in terms of what they're pushing, and then also talk a little bit about Kotlin sort of goals in making sort of this Kotlin everywhere work, which is really cool. So I always think of ASP.NET as sort of the primary thing that I see people using C# for. Most of my friends who are C# developers are writing stuff in ASP.NET Core. How many of you guys use ASP.NET Core or even ASP.NET like every day? Yeah, exactly. I figured a lot of you would. How about cloud apps? So writing functions, running background jobs, doing stuff in Azure that's not necessarily just a web app. How many of you guys are out there doing that with C#? Okay, a little bit less. My calculations are right. What about Windows developers? WinForms, WPF, UWP, anything like that? Closer? And how about Xamarin devs? Where are my Xamarin people at? I love you guys. All right, Kotlin has a number of different platforms like we talked about. Sort of along the same lines, you can use the Spring MVC framework, which is a Java framework, or you can use from the Kotlin team this project called Ktor, which is like, it's ridiculous. It does a lot of sort of server and client side communications where you're actually writing Kotlin for JavaScript that gets compiled. You also have Kotlin for the back end, and you have sort of your APIs and everything else. It's really cool. Those of you who have used Kotlin, the like 4 of you that are in here, any of you guys messed with that stuff yet, or is it all Android dev? Yeah, I figured. Okay, same thing with cloud apps. If anyone's using AWS, Kotlin is and especially GCP, Kotlin is finally sort of like coming up as like a proper platform to write code for. Mostly because it's all the same stuff for JVM. They're just having you compile it and run it in the same places you always have. And sort of the big one that I see, and this is how I got introduced to Kotlin, was with Android development. And about 2 years ago at Google I/O, Google had announced that Kotlin is finally going to be one of the official supported programming languages for Android development, which is really cool. How many of you guys have done native Android development with Java before? And how many of you guys have started to do it with Kotlin? See, this is where this is the transition I want you guys to make if you have to do it again. So there's a lot of other platforms both of those supports. Let's go through some of the lists in C#. So IoT, we can write stuff on the edge with C#. You can do it with UWP embedded. You can do it with some of the new stuff. I don't know if anyone's been following the Meadow work that they're doing with the new boards and stuff like that, which is pretty insane. I'm sort of heavily invested in that. I'm really waiting for my stuff to come in to do some more IoT in C#. We have Unity. We can build really great games in C#. We have the original Mono, which is still very relevant and sort of the backbone of everything from Xamarin. We have Uno, which is a newer platform to sort of bring UWP everywhere. That still lives sort of on top of Xamarin, same idea. And of course, Blazor. How many of you guys have gone any of the Blazor talks here? Or taken a look at Blazor? If you haven't, I recommend it. It's pretty insane. Being able to write WebAssembly in C#, it feels like Silverlight, but it's not Silverlight, so everything's okay. So Kotlin also supports a number of platforms. And sort of what I see as a priority is iOS. And I'll show you in a little bit sort of what I mean with they're pushing iOS as an actual platform to build for. And like I said before, we can also compile the JavaScript. So that's a pretty important platform to build for. And then anything native that's using the low-level virtual machine. So we can compile it, run it on the LLVM. Anything we're writing in Kotlin can now basically run anywhere. And then, of course, anywhere where there's a JVM. How many of you guys have had to install Java and you see running on 100 bajillion devices worldwide? All those places can also run Kotlin. So sort of looking at that list, the only platforms that like one supports that the other doesn't in one way or another is like Windows. You can't really do Kotlin for Windows yet. And JVM, we can't really compile C# and run it on the JVM yet. And I can't wait to talk about that with some of the stuff in .NET 5. But that leaves like literally everything else that both of these can support. So I think it's important to know that we actually have options for people that want to write with good programming languages. If we want to stick to C#, we can do that. If we need to venture off and someone's like, hey, I really need you to work on this Java thing, you can be like, I'm not going to work on this Java thing. I'm going to work on this Kotlin thing, and it's going to be good, and you're going to be able to read it and understand what's going on. So cool. Any questions about any of the platforms or any reason why you might want to write in Kotlin? Cool. So let's get back into the code then. I want to talk about object-oriented programming. It's a very important aspect in C#, especially compared to some of the other CLR.NET languages. And so I want to compare that, obviously, in this talk to Kotlin and its object-oriented roots. So although I mentioned that Kotlin does support functional programming, I want to sort of like stray away from that. Let's focus in on the object-oriented bits, and then we'll sort of compare and contrast, dive deeper into some of the cooler features that they both have. So, old slide, you guys have seen this. The sort of foundation that we need is an object, and so we have the ability to define our class. But let's make sure we can actually fill in sort of the 4 or 3, depending on who you talk to, pillars of object-oriented programming. So let's go back into our computer science days and talk about abstraction. We need to be able to create and handle inheritance. We need to be able to do encapsulation. We need to control what properties or classes, functions or methods are accessible by what or by who. We need polymorphism, we need inheritance, and we have all of those with both of them. And one of the core things in order to support this, and I'm going to sort of go sort of root feature by root feature here, but the first one I always think of is interfaces. So in order to support things like polymorphism, we need to be able to define interfaces. And so in C# we can do that. Our interfaces are simply contracts, at least in C#7. We don't have default implementations. We can do default implementations in C#8, and I'll show an example of that later. But in this example, we have our iAdoption service, and we have our 2 methods, one that's called adoptDog, takes in a dog, one that's adoptDogs, and that takes in a list of dogs, and then we have an implementation of that does the logic of setting the isAdopted flag to true, and then another one that loops over it and calls its own method there for adoptDog. In Kotlin, we do have default interface implementations. That's mostly because Java had it from the get-go anyway. It's one of the features that I actually missed when I first sort of switched over to C# from Java, but now writing a lot of Kotlin, I get that back, and it feels good. And in C#8, I get it, which just feels even better. So in this case, same deal, we have an interface. Notice the naming convention, we don't have the I. Instead, we're sort of sticking with the Java naming convention of the interface as the default name, and then we slap that impl on the end like a monster. So we have our interface, we have adoptDog, which is not implemented. So this needs to be implemented by anything implementing the dog adoption service. And then we have the adoptDogs, which has the default implementation. It's going to do a for loop over each of the dogs and the parameters, and then call the adoptDog, which is referenced above it. And so in the implementation, we just have to override the one method. We can also override the adoptDogs one, which takes in the list, but because we have the default, we'll just continue to use it. And so instead, we just define adoptDog as true, but now because the interface knows that there is an adoptDog, it has the contract of what that should do, it can still reference it without referencing an implementation, which is pretty cool. So encapsulation is pretty big. C# introduced a lot of different encapsulation keywords that other languages didn't have. So in this case, I'm just throwing a whole bunch of them in here, right? So we have a public class. We have a public property, which is a string. We have a protected int, which means that anything that's inheriting from dog can also access that age property. We have private breed, which means nothing but this class can talk to it. And we also have a private class within that, which then also has a public property, meaning nothing outside of the dog class can talk to breed and reference it, but dog can reference any of the public properties within it. Kotlin, we have sort of some different defaults, which is interesting. So one of the things you may have noticed when we were defining properties back at the beginning is that we're just like var, name, boom, done. Default public in Kotlin. Not the design decision I would have made because that's sort of like letting people worry about what to secure rather than default secure it and let them be aware of what they're making accessible. But it does make it quite verbose since most code is usually public that people are writing, good or bad. We have private, same deal, only dog can reference it. We have the private data class breed, which then has a public val name, so the exact same scenario. We also have the same protected, same deal, anything inheriting from it can reference it. But there are a number of other keywords too. So in C# we have the idea of a sealed class, meaning that nothing can inherit from it. it's the same concept as final. One of the things you might have noticed, I'll go back for a sec, is that we actually have this open class dog. If we want to make something inheritable that's not an abstract class, we have to actually say that it's an open class, meaning something else can inherit it. Default, public, and final, everything in Kotlin, mostly because that's how Java developers write anyway, and I'm sick of reading public final. So we do have the concept of final, which is default. You can still explicitly write it. We have that open concept in Kotlin. In C#, we have the idea of virtual, which means that you can override it if you're inheriting a class that has something virtual. We have internal in C#, which means only anything within its packages can talk to it, and then the default, which depending on where you're using the default is either private or basically some form of private. For Kotlin, we also have internal, same deal, only packages that it's in can talk to it. And we also have an idea of external, which is cool. It's the exact opposite, right? So nothing within the package can talk to anything external. And at first I was like, why? Like, who's using that? And then I actually ended up using it. I was working on basically a little library for people to consume, and I wanted to sort of make all of those public methods I want people to call external, which is an interesting concept because then my stuff can't call that. But it does make sense because then it's sort of defining the data contract for my library in terms of what people are going to do, and I'm not going to mess it up by using it internally either. I don't know, it's kind of cool. I haven't really seen that anywhere else. I probably really didn't even need to use it, but I thought it was a neat concept. So on top of interfaces, we have abstract classes, and I'll answer the question before it's asked of, well, if we have default interface implementations, what is the point of a stupid abstract class then? So in an abstract class in C#, we can actually use it almost like the default interface does. And in this case, there really is no difference. We have the adopt dog, which is abstract, meaning it has to be implemented by something inheriting it. And then we also have the implemented version of adopt dogs, calls that abstract method. Pretty cool. It doesn't need to know about the implementation. Then we have the inheriting class of the adoption service, the dog adoption service, that actually implements that adopt dog abstract method. So in Kotlin, same exact concept, just like we saw with the default interface implementations. I'm pretty sure when I wrote this, I literally just like changed it in the slide from like abstract class to interface, but it is really similar. The difference with the abstract classes is that we can actually define getters and setters and public properties and private and protected stuff in our abstract class that we can't do in our interface, because our interface can only be aware of properties that can't reference fields and methods that need to be implemented, or funds, if you will. So on the not so pretty side of object-oriented programming, we also got static stuff. So C#, just like every other sort of C-style language, we just slap static on everything. So in this case, we have a static class, which means anything in it needs to be static, and we have this static void adopt dog. Same old thing, right? We're just setting a property. Kotlin has an interesting concept and a naming convention for it, which has been growing on me. When I first looked at it, I was like, what is this? Why? And the next one will show it even more. But instead of having like a static class, we actually just have an object. And it makes sense if you think about it. If we have a static class within sort of a package or within a namespace, when something is basically referencing that entire package when the application starts up, it's initialized, right? It's initialized from the get-go. So when you're reading it in Kotlin, you actually think like, oh, that's just an object. I just always have that sort of instantiated object, and that's exactly what it is. And then when we get into sort of functional style programming where we don't even need packages and we can just like throw stuff anywhere and nothing needs to be in a class, this actually comes in handy. So outside of static classes, we can have static members. So in this case, we have a service not static, but within it, we have that static adopt, and then we also have the non-static instance adopt. So in C#, all we have to do is slap the static on the method, and then we can reference it just like we would in the previous example, where we can just say, you know, adoption service.static adopt versus having to new up the adoption service to call the instance method. So this is where it was really confusing for me to pick up at first, because to have a static member on a non-static class in Kotlin, you actually add what's called a companion object. And it basically means like, hey, we've got this object, right? It's always instantiated, but it's just going to kind of like tag along with your class if you need it. One of the things that's interesting about it is that when you reference it in Kotlin, or if you reference it in JavaScript when it's compiled, you reference it like you'd expect to reference a static method, right? So in this case, here in this run function, we have adoption service.static adopt, just like we had in C#. But if you reference this in Java, you actually have to call adoption service.companion.staticAdopt because it's actually going to initialize a static class within it, which is that companion object, which is pretty neat. Again, it was a little confusing for me at first, but for the concept of having a static member, a static property, a static function, something like that, on an instantiatable class, you just slap it in a companion object. Anything you put in there, though, is then static. So in this case, we only have the one function, but within our companion object, that's where we would put all of our static stuff, rather than having to have like a bunch of companion objects and each one is like wrapping the function or property. We just have it once, and then everything in there is sort of what belongs to that companion. So one of the things C# did really well, and one of the recent-ish, right, not an original feature of C#, is extension methods. And so this is where a lot of people I write code with abuse, and they're like, oh, throw in a helper and a utility and an extension method, and it'll do all the magic for you, just call dot whatever. I think when it does have a great use case, it's amazing to use, right? So we have things like link extensions on all of our collections, and all we have to do is call dot where, dot select, and it's pretty great, and all that's defined in a separate library than iCollection is. So in C#, we have our adoption service, and we have our existing adoptDog instance method, and then we have to create a static class to put all of our extensions in, which is kind of interesting. So in this case, we have our adoptable extensions, and then we have that static adopt, which then takes in this keyword in order to tell you that the dog is the context again, and that's what the extension is being applied to in terms of the type. In Kotlin, it's a bit easier to read, sort of following along the lines of reducing verbosity. I mean, you can even just see, like, compare the lines of code. We're shortening it by like 4. So same deal. We got an adoption service. We got a public function called adoptDog. It calls dog.adopt. And we're able to do that because we just defined this extension function by just saying, this is a function. I don't care where it is. It could be in not a package. It can be in sort of the global namespace, or it can be in a specific namespace, or it can even exist within another class. You can just slap it wherever. But you just call adoptable dog.adopt, and then you define the function there, which I think this is a really cool way to write extension methods. I don't have to shove them all into sort of one folder called extensions and then have one for each type that I'm building extension methods for, which I know a lot of other people do. And it makes it very terse and very easy to read and very easy to follow, because now I can also kind of contextualize my extension methods. I can have this extension method exist only in this one class that needs to use it. It's no longer this globally accessible static method that someone can abuse. I can actually scope it properly. Kotlin also has extension properties. Basically, they're able to do this because of how they handle, again, that translation into an actual method for things like Java, right? So in this case, we're actually giving adoptable dog a name property, and it's just a calculated get. So this can't just be an open-ended property. It has to have an explicit getter, setter, or one or the other. So in this case, we're combining like a first name property and a last name property, but we can actually just access it as you'd regularly expect to. We can actually also extend companion objects, which is cool. And you can actually see that naming convention I was talking about, where we actually have to call .companion. But it's interesting because the same idea, like I saw this as a feature, and I was like, when am I going to do that? When am I going to need to add a static member to a static class? Who's making these rules up? And then I did it once, and I was like, oh, someone ran into this use case, and I thought of it ahead of time for me, which was pretty cool. But again, it comes down to being able to sort of like scope those extension methods. So in this case, if I have the need to have a static member called getShelters or something like that, but I don't want to just allow anyone to sort of access it. I don't want anyone that's consuming my package to be able to use it. I can actually scope it to a certain class and define it within a class that's outside, or within a package that's outside of the adoptable dog companion object, or outside of the library entirely, which is pretty cool. So another thing that C# does really well is a lot of this sort of like leaning towards a little more dynamically typed, with a lot of type inference and stuff like that, or even the disgusting dynamic type. How many of you guys actually have used dynamic in C# a lot? Okay, thanks, guys. I'm opinionated on it just because it makes it very unstable in certain cases, but doing heavy calculations and stuff like that, it is a lot easier. Just dynamic, but you're sort of working under the assumption that you know what you're doing, which is dangerous, but it's also a lot of fun if you do it right. So in this case, we have an example where we're taking in the dynamic pet. We can work under the assumption that it has this is adopted. If it doesn't, we're going to crash at runtime. If we pass in some random class or some object, or we just pass in a string or something, that's not going to work. So Kotlin kind of has this, where, again, the same thing you should define as a dynamic type, but this actually doesn't work in the JVM. And that's strictly because the JVM needs to understand ahead of time what your types are, but if we're compiling to JavaScript, all of our objects are dynamic. No one cares anyway. So if you're writing Kotlin code that's meant to go to JavaScript, you can slap in dynamic types at any point, which is pretty cool. All right, let's look at type inference. This is one of the coolest things that sort of Java developers coming to C# are like, this is gross. I need to define my types everywhere, but I think it's pretty cool. So in this case, right, we have a method called pet exists, and it takes in a predicate. In this case, it's an expression of a func, but it could also just be a function for the sake of the argument. But I did want to show it because basically when we're executing pet exists, we're actually making two different type inferences here. Because all I have to do is p arrow p id equals id, right? Which is, it's neat. I understand what it is because I can read the code. I can go to pet exists, and I can say, oh, that is taking an expression of a func of adoptable pet, needs to return bool. But it's really terse and easy to read without having to read through all the types and everything else. So we're actually making two different type inferences here. We're making an inference on the parameter type, so just the whole expression there, that could just be a func, or it could be an expression, but because it matches either, we're able to just assume that it's going to be an expression, instantiate it as an expression. But then within that, we're also instantiating p as an actual adoptable pet rather than just sort of any object, which is pretty cool. We get a lot of the same goodness over in Kotlin, which for any of you guys who have written Java recently, you'd understand that like Lambda functions aren't a thing, and like they're allegedly going to be a thing, but Kotlin's like, we're going to make it a thing. So some weird things to read here, which makes it a little bit different coming from a C# perspective. So same idea, right? We have a predicate, and this is taking in basically a func that consumes an adoptable pet and needs to return a bool. So we define those funcs with the input types as a parameter, and then a little arrow, and then what the return type should be. And then on the sort of execution of that, we actually don't call it with parentheses. We define it with braces, almost like we're creating a new function. And that is essentially what's happening underneath. But you'll see it everywhere. Where anywhere you're passing in a predicate, you're passing in a function, you're passing in any sort of executable code as an instantiated bit. We're passing it in brackets rather than parameters. So in this case, we have the brackets p to id. Again, we can now work with the type inference that this whole thing is the proper predicate type, and that p is an adoptable pet. Generics is also really important, and one of the things that C#, in my opinion, does a lot better than other implementations of generics is these sort of restrictions, right? So I can say a pet adoption service of type T, but I can enforce the rule that T has to inherit from adoptable pet. I can enforce that it has to be a class. I can enforce that it has to have a constructor that takes in certain parameters. We can do a lot with that. And we can do all the same things with Kotlin. And in my opinion, it reads a bit better too. So you'll even notice sort of when I had to write this in C#, I actually had to new line it in order to make it fit on a slide. But in Kotlin, I actually have a larger font size here and can still fit it in because I actually say T has to inherit from adoptable pet right in the actual braces where I'm defining the generic, which is pretty cool. And all of the types sort of work that way, but now I can actually consume T. I know T is going to have an isAdopted flag, just like we could make that assumption over on the C# side, and then we're basically off and running. Another thing that is sort of a newer feature in C# is tuples. How many of you guys actually use tuples in C# regularly? I love tuples, but they're another thing that people can abuse pretty easily. But in C#, I love the way they define tuples. So in this case, right, we have this data parameter that's going into this adopt method. And that takes in a tuple where the left type needs to be dog and the right type needs to be shelter. In C#, I can just add more and more and more types to this, so I can have a tuple of 13 different types that I need to pass in. I can name those types. I could, instead of just passing in dog and shelter, I could say dog, and it is of type dog, and so now I'm going to have the object's property name that I can access. But in this case, because I'm not defining it, all I have to do is call .item1. I now know that is that dog class, and so I can hit that is adopted property. So there are tuples in Kotlin too. They actually have some cool aliases for basically shorthanding tuples, where if you have 2 or 3 different types, you can just call it a pair. And you'll notice you get the first, in this case we're using a pair, same thing, dog and shelter. And we get the same sort of aspect where in C# we call .item1. In Kotlin we're calling just .first, and then we call .second to get the second one. That's pretty intuitive. We don't have to have numbers. It kind of makes sense. You can also use the type called triple if you have 3 different objects going into your tuple, and you just call .first, .second, .third. And then beyond that, you actually have to just call tuple type, and it's just the generic. So this is actually one where it was kind of interesting, where they did take a more verbose approach. I'm not sure if that'll change in the future once they realize like other people are doing it shorter, and they're like, well, we want to be the shortest one. So we'll see. But I actually like the whole pair idea because it reads a little bit better. So I think one of the most important topics to talk about is asynchronous programming. I'm not going to spend a lot of time on it. I can spend days talking about it. The session right after me is going to do a big deep dive into coroutines and asynchronous programming with Kotlin. If you're going to be around and you're actually still interested in Kotlin after this, which I hope you are because that means I'm doing my job, stick around because Svetlana's going to do a big deep dive into asynchronous programming, which is actually a newer feature with coroutines that came out in that 1.3 I was talking about. And they do some pretty crazy stuff. But let's just talk about sort of the basics in this case, right? So in C# we got async await, which is awesome. We were one of the first people to implement easy asynchronous programming. Made all of our lives like 100 times easier. I don't have to care about threads. I still probably should. I don't necessarily have to care about task management and stuff like that. Again, I probably should because a lot of people do it wrong. And in this case, this isn't necessarily the best code, but I rate it to fit on a slide. So in this case, right, we have an async task called background get, and we're just awaiting another async task. Easy. In Kotlin, we have this concept called coroutines, and there are extension libraries you can install which actually give you async await capabilities, but coroutines on their own can do quite a bit, and you can define a whole bunch of different scopes for your coroutine. So in this case, we're essentially saying take the global scope, just add a global coroutine and do it, sort of your traditional fire off this async task. But I can actually define my own scopes. I can nest scopes within them. I can add extension methods to these scopes in order to execute things sort of in a process. I can also, within the execution of a coroutine, just say like pause after this thing's done. All right, now continue with that coroutine that was in the middle of running. And I can also actually do things like bring it up and sort of join coroutines together, string them together, await them all, just like we can sort of await a bunch of tasks and stuff like that. So now that I'm done rambling about how awesome they are, this simple example where we're just calling background get, all we say is global scope.launch. That's kicking off a new coroutine, and then we pass in a method. You sort of see that same thing where I was saying, because we're passing in a function to be executed, we're using those curly braces, where sort of traditional C# development, this would be like passing in a task as an object. We would do it with parentheses within that launch function. So in a real-ish world, example of async await, I wanted to take a sample that I think we're all too familiar with, and that's getting something from the internet. So in this case, I'm newing up an HTTP client. I don't even care about disposing it. I'm running wild over here in my method. And I'm also just calling get string async. I'm not calling get async. I just know what I'm going to do. I'm going to take the performance hit. I'm going to assume all exceptions are never going to happen and everything's going to be good. But in this case, I'm awaiting that method, which is just going to go hit some URL and get me the string of the response. And then I'm going to deserialize it, right? And so then in our background get, all I have to do is have a list, and then I can kick it off in a background task, which can set the dogs. I have to work under the assumption that background get is going to be held by a parent context. Otherwise, I should have used like task factory or something like that. But that wouldn't fit on my one slide, so no way. So similar example with Kotlin. We get the JSON from the URL by instantiating a URL object, and then we just call read text. Again, probably shouldn't do this. That's a synchronous call, keep in mind. And then basically we're going to use JSON and like it's Google's JSON library, think like JSON.NET in the Java world, and do this whole gross type thing that I have to do here, which is just how JSON needs to work because Java doesn't handle certain things very well for deserialization. And then basically we're actually creating that adoptable dog type from that JSON. And then to execute that in the background, I have my instantiated list of null for a list of adoptable dogs, and then I'm setting that in the background after it's been launched in that coroutine. So basically think of it like something's going to call this get adoptable dogs in background. I'm going to launch a coroutine, but that get adoptable dogs in background needs to hold on to that dogs because my coroutine is actually going to come and set it after the fact, which is pretty interesting. There is also the sort of simple way to await the coroutine. I just have to take a reference to that global scope.launch. In this case, I just call it task because we're all C# developers, and just call .join. And that's basically going to wait it. But basically, because I'm working on like a current thread, sort of my main thread, if you will, I can take my coroutine thread that was just spun up and then join that coroutine to my current one. So this is what I was talking about, where we can have like nested coroutines and we can like join them up to each other, keep them all in the same context and everything else. So I'm done talking about sort of these default code samples. Does anyone have any questions? Because that was quite a bit of just code on slides, right? No, awesome. So talking about tooling, for C# developers, we have some of the best IDEs in the world, regardless of what language, right? We get to use Visual Studio. VS Code is there if you're doing stuff with the CLI. We can write C# on the Mac with VS for Mac. And yes, I know I need to update these icons to 2019. And we can even use JetBrains Rider. If you've used Rider before, it's pretty cool. If you use ReSharper, it's essentially ReSharper in an IDE. I haven't really used it full-time enough, but one of the things I do use is their Java editor called IntelliJ. It's basically, Rider is like IntelliJ for C#, which is pretty cool, and they have a ton of stuff built in for Kotlin in IntelliJ. Android Studio, which is sort of the default, it's free, totally free. Google built it for you with support from JetBrains, which basically it's living on top of IntelliJ with a whole bunch of Android stuff built in. This is sort of where I started with Kotlin back in the preview of Android Studio 3. And then if you feel like it, you can use Eclipse with some stuff, I guess. So I want to talk about sort of future state for both these languages. We've done a lot of talks about C# 8. You've probably sat in on a few. You probably already know some of this stuff. But I want to sort of provide more of that context for like, hey, this cool stuff that's coming out in C# 8, that stuff either already existed in Kotlin, or it's coming out in Kotlin, or there's basically some way to do it that's still pretty neat. So first things first, nullable reference type. I tried turning this on in one of my projects and then turned on warning as errors. I don't know if any of you guys have done that. I came up with like 8,000 errors, which is just gross. And I feel like I'm just a bad developer because that happened. But in this case, right, we're looking at that same Poco to Pojo to Poco with a K example, where instead of just having default string, we're actually explicitly saying this is a nullable string. And so now it looks a lot more similar to the Kotlin example where everything is nullable reference types from the get-go. We also have the new concept of ranges. I haven't really used this in production yet other than sort of playing with it in the C# 8 features when they were first announced. But basically the idea is I can take a list or any sort of I collection and just cast a range to it and actually loop over that. And this is another one where C# did it really well. Kotlin does have the concept of range, and we can define it as a type. There isn't like basically a selector, helper, or extension to do it. So in this case, I'm defining the range, and then I'm just going to call sublist, grab the first and last thing in the range. But you can do also this exact same thing we're looking at in Kotlin and do it on the C# side, where you can define your range as a variable of range, which is a value type, and then sort of carry on. So I've talked about this a bunch of times already with default interface implementation. So C#, we're getting default interface implementations, which is awesome. Basically, it works the same way as it does in Java, and so it works the same way as it does in Kotlin. And so now these two are also looking a little oddly similar. We have our iAdoption service, we have adopt_dog that's not implemented, and we have our default implementation for adopt_dogs that references up to the one that's not implemented, and then all we have to implement is the adopt_dog single one on both of those, which is pretty cool. Asynchronous streams. This one I was really excited about because I do quite a bit of work with a lot of sort of real-time data. And basically, this gives us the ability to have almost like a list of awaitable tasks. So in this case, right, I'll sort of break down the example. We've taken a list of dogs, and we want to get their names in a stream. So in this case, I'm just task delaying on each one, but then I'm yield returning each of that into the list. And that's going to return an I async enumerable of the type, because in this case, I'm returning the string name property. And so when we execute that, we can actually just loop over that as you normally would, and we can actually get that name. So each time we're going through the loop, we're getting to that get names async again, and for each one in there, we're actually waiting to get that response. So we're going to wait 200 milliseconds. It's going to hit the next loop cycle, wait 200 milliseconds, next loop cycle, and stuff like that. C# did this so amazingly well. Kotlin is possible with Kotlin, but as you can probably tell, this is getting a little hectic. So in this case, I'm actually creating custom scopes for coroutines, and then basically breaking down each of the methods. So I have the ability to get a name asynchronously by creating this extension on my coroutine scope, and again, just delaying 200 milliseconds and return the name. And then I have the ability to get those asynchronously, where I'm actually calling like a map function, and I'm calling the async name. So now I'm actually returning a list of deferred strings, nullable strings, and then I can loop over them, and I just have to call that .await. So basically, there's a little bit more work to do with it, but you can still get that actual sort of sensation of streaming each item in the loop, because by the time we get to name.await, we're awaiting that full one that does the 200 milliseconds. We hop back up and check the next item in the loop, where basically the difference between the two is that in C#, we're waiting when we're getting to the next loop. In this case, we're actually waiting in the loop, and then we go to the next one. So Kotlin's got a lot of stuff going on too. There's a lot more work being done with coroutines. It launched into production in 1.3. They did a release literally like 2 days ago, actually, which enhanced a couple of different things. They're doing a lot more in native development, so trying to get the LLVM stuff to work better, doing more project templates and stuff like that to work with iOS. There's a ton of IDE enhancements that are always coming out. Android Studio feels like they have another extension you can use every day. So for the Xamarin guys out there, did you remember when Miguel was finally like, oh, you don't have to, in Xamarin.Android, call find by ID anymore. We'll just get it for you, because that makes sense. We had that from the beginning with Kotlin, which was pretty cool. And what's being pushed a lot right now in sort of the Kotlin community is multi-platform projects. So being able to have one code base that can be your web server and share logic with your client side that's running in JavaScript, which shares client with your iOS app and your Android app, which all share their same state logic, but just have their different UI components and stuff like that. And there's a lot of community projects around that too, where we're getting almost like a Xamarin Forms implementation in Kotlin, where there's a shared UI now, and then that's being spread across the different platforms, and all of the sort of shared state happens in a shared library, in a shared package. And they're calling that Kotlin everywhere. And I mean everywhere. Now you can actually come into IntelliJ, just go down to a section for Kotlin rather than just going to Android and being all right, I'll do an Android app, and yes, I'm selecting Kotlin because I'm brave. In this case, we can just pick the different project types. We can do a JVM project if we're just doing something in Java. We can do just JavaScript. We can do just native. We can do basically the KTOR stuff, JS client, JVM server. We can just do multi-platforms. Really, give me all of them, and I'll tell you which ones to delete later. You can do mobile with just Android, mobile with Android and iOS, and then sort of that shared library for mobile too. And so one of the things I'm really excited about is a potential for these to work together. And this is something that, the last time I gave this talk, right before build, wasn't a thing I could talk about, but .NET 5 is coming out in 2020, and one of the things that they just kind of snuck in there, and all the cool stuff you're going to get with .NET 5, better perf and all that, and they're like, oh, but also we're going to have 100% interoperability with Java, and they just kind of toss that in. Oh, and we're going to have interoperability with Swift and Objective-C on iOS and macOS, and so now we sort of get this idea where if we can actually take Java code and then run that in .NET, we can write it in Kotlin, we can write in C#, those things can actually work together. And now both of those together could literally cover every platform. If I can write Kotlin where I want to, and I can write C# where I want to, I can also then stay on top of what features I want to be working with. And I'm really excited about this. I'm hoping that by the time .NET 5 comes out, we do have that implementation of the interoperability, because I'm going to be jumping on it and building tools to connect these two, because I'm so torn between them all the time. I literally have a talk because I'm so torn between them. Someone write Kotlin with me, please. Okay, let me summarize what happened. Both these languages are awesome, right? Can anyone agree with that? Kotlin seems pretty cool. Anyone who hasn't used Kotlin before think Kotlin seems pretty neat? anyone who's like, nah, C# is still better, I don't care. Yeah, I get that. But one of the things I want to emphasize is that like we really did just barely scratch the surface with Kotlin here. We didn't talk about any of the functional stuff. We didn't really talk about design patterns and how easy they are to implement in Kotlin. We didn't talk about some of the deeper language features. We barely scratched coroutines. We didn't talk about doing the async and await with coroutines. We didn't talk about Enco. We didn't talk about native. I didn't show you demos of it. I just showed you code snippets. So if you want to learn more, if you're interested in the Android side, I've got a Pluralsight course called Building Android Apps with Kotlin Getting Started. We do a whole app from the beginning, assumes you know nothing about Android, and assumes you know nothing about Kotlin, and you get to actually build a real-world app, which I won't spoil too much about. So resources for this talk, every little code snippet that was there, that's up on GitHub. So if you want to see that, compare and contrast, I have both projects in one repo. Clone it, look at them both, pull them up in code. There's Kotlin extensions for code too, if you feel like just looking at it all in one place, which is cool. Check out the Pluralsight course. I have a whole blog series on this stuff too, specifically for C# developers, so doing a little deeper dive on comparing async await to coroutines and stuff like that. And I'll put all these slides up on Twitter too. It's up there from like older talks, but I want to get the updated stuff. And if you're going to stick around, hang out for Svetlana's talk. You know, like I said, coroutines are sick. I'm going to be hanging out here too, so I'm going to go out and grab a drink. If anyone wants to come and ask me questions, I'll be in here for this talk and learn a lot more about coroutines and asynchronous programming in Kotlin. And thanks, guys.